Next, I'd like to bring up to the podium Dr. Scott Kopetz. Dr. Kopetz is a GI medical oncologist and associate professor at the University of Texas MD Anderson Cancer Center. He is the recipient of 2 Hope Awards and has promised that he would keep his slides under 50, you said, right? So, excellent. He has a lot of research to share. Please join me in welcoming Scott to the podium.
Wonderful. Thank you very much for the invitation and for setting the stage high, because I think I'm supposed to accomplish twice as much having received 2 awards. But I would just like to start off while the slides are, oh, here we go, and just really, thank the Hope Foundation for really, I think as you saw, the circle really being integrated within SWOG. And I think that is such a critical part of what the Hope Foundation can do, because it really is that constant back and forth play of the research, the developing ideas, bringing them into SWOG, but also learning from what we're doing in SWOG and in the studies to take back to the lab. And so I'll try to share in a vignette how we tried to do that both with the Seed and Impact Award from SWOG. So the problem we are tackling is one in colorectal cancer, where there is a particular mutation within the tumors in BRAFv600E. And this is one that is shown with Dr. Blenke's leadership and others in the CA-LGB SWOG 80405 study. Just reiterating, these are patients that have very poor prognosis with our standard therapies. So it's a tremendous unmet need. And although its population is under 10% of all colorectal cancers, it's also one that we know that, as shown now several years back, that when we just treat with a standard BRAF inhibitor, despite the fact it's a BRAF mutation, in this particular type of tumor, we just don't see the activity. And so this is the understanding that has led to the advances in this field is that this is really a problem of network rewiring, of that these are tumors that are not sensitive to EGFR inhibition, unlike other types of colon cancers, but that when we inhibit BRAF with a BRAF kinase inhibitor, the tumor adapts by now reactivating that EGFR pathway. And that was a key understanding that then led to a number of additional studies, including studies that I'll show, that allowed us to now hit the tumor and then hit the adaptation of the tumor to that inhibition. And so this is what it looks like in the mouse models when we take a tumor and treat with a BRAF inhibitor, no activity, with an EGFR inhibitor, no activity, but when you put them together, you get a wonderful synergy in the mouse models that really says that this is heading the right direction. And so with colleagues at MD Anderson, we did a phase 1B with a BRAF and an EGFR inhibitor with some chemotherapy, and we're starting to see response rates and durability that increased. And we developed what we call the VIC regimen, or vemurafenib, irinotecan, cetuximab. And this led to the SWOG 1406 study that I was fortunate enough to lead as the PI, but with many great collaborators within SWOG. And this was a population of patients, again, BRAF mutated in 2nd or 3rd line, where they either received standard therapy with cetuximab and irinotecan or had that additional BRAF inhibition provided as well. And this was a study that we'd reported out that was really a tremendous success in enrollment. And I think this is really a testament to SWOG, because SWOG was the #1 enroller in this intergroup study by far. But where we're looking for a rare population, we said we'd love to get to 105. We set our original target date. We exceeded that, so we said that's great. We'll revise our target rate, and we exceeded that again, and we're able to enroll this in a very rapid manner. And the study itself was a positive study, the hazard ratio of 0.5 for the primary endpoint of progression-free survival. And we were seeing responses in patients, so 2 waterfall plots of the control arm and the combination arm. and you can clearly see that, the benefits that we are providing, and even in patients who are on the control arm, then crossing over and able to induce activity in the crossover arm as well. And so this was, I think I'm very, very pleased to say, in the basis of this SWOG study. Just a few months ago, this regimen was added to the NCCN guidelines. So this is a new standard of care and really the first treatment for this, this very refractory population. And so this, I think, now has enabled a lot of patients to be treated with this. But it also recognizes that this isn't the end of the story. And that, I think, was the exciting part of where, with the Hope Foundation support, we've been able to not only help bring it to this point, but also to say this is a tremendous opportunity that we can now learn from and how to move forward. So, some of the, one of this Hope Foundation awards allowed for us to do an on-study biopsy to actually generate patient-derived xenografts from patients. So this was a few years back. This is a concept that the NCI was not quite sure about, so it was a little bit of a challenge, but I think a wonderful challenge to really push forward. And now this has been kind of accepted as something that can be done in cooperative group studies. And it's also a great collaboration with Jackson Lab, and I think that's the other great opportunity to bring together the expertise that's needed. So what did we do? We took patients from the 1406 and the earlier study as well, and had these on-study biopsies that were done. And the question is why? How does that help us? Well, part of the question is really this idea that these patient-derived xenografts now are increasingly recognizing that, unlike perhaps cell line models, these patient-derived xenografts match what's happening in the clinic very nicely. And so this is some work showing that when you look at what happens in the mouse models, compare that to what happens in the patients that are on the studies. So when you derive these on-study PDXs, very nice correlation. And so what it allows us to do is to ask questions about, well, when we're giving combination regimens, what was it that worked for that patient? And so this is work from the Hope Foundation support with Van Morris, who's a very talented faculty, junior faculty, and MD Anderson. And what we did was show that with these PDXs, again, from patients on the studies, we could identify groups that benefited from the BRAF and EGFR, and when you gave some cytotoxic chemotherapy, they benefited even more. There were those that really needed the full triplet in order to get there, and there's some where the chemotherapy alone was doing it, and it actually wasn't the combination of the targeted therapy like we thought. And so this is one opportunity to really tease out, you know, the complexities of a regimen, because we obviously know a given patient in front of us we can only treat with one regimen, and it's hard to know what would have happened had we delivered it in a slightly different way or with a different combination. Now, the other advantage of it is that this allows us to then do things in the mice that help us predict what we can see in patients. And so with these patient-derived xenograft models, we can treat for an extended period of time with the chemotherapy, and then we can try to understand the mechanisms of resistance. And we know how hard it is to get these biopsies on patients after progression. It's such a difficult time. We'd love to be able to get that information, but it's just not always feasible. But what this allows us to do is to really, in a robust way, to do that and to really categorize the mechanisms of resistance. And so we're able to do this with the PDX models, and we could actually generate a whole library of things that we could potentially see in the patients. And we can actually do this before we have the studies. And now we can actually know what to look for in the patients. And so this is a great example where we could predict ahead of time what the mutation profiles were. Now we could actually go to the patients and look in the circulating tumor DNA, for example, and actually see how often do we see these mechanisms. And so this allows us to be much more focused in looking at mechanisms. And so in this, we actually saw these mechanisms in almost half of patients who were progressing on these combinations. So, so we can then use these models for discovery. And so the Seed Grant with Chris Liu and also with Van Morris we're able to take these resistant tumors that now had developed resistance to the regimens like the VIC regimen, and now start to ask what sort of things can we do that would improve outcomes. And so this is work demonstrating that it's MAP kinase pathway reactivation that really is driving resistance. And this has now led to another follow-on study, proof of concept study, where we're actually now seeing the progression-free survival double what we were seeing in 1406. And we hope that, that this will be the next path forward. And so this is information that came directly out of these mouse models that we could build. But we can also use these to explore other areas, and I think this is just some initial preliminary data looking at other combinations for the other portion of patients that we really are having a hard time with, which is the KRAS mutated tumors. And patients with a KRAS mutated tumor really don't respond to many of these inhibitors. And so now with some of these screens, we can now see, again, very nice synergy of other combinations and other pathways. And some of those very early toxicity studies are being done. But the idea is this is now a pipeline that we hope can feed additional SWOG studies moving forward. So I think the hope was to kind of share some the story and how the Hope Foundation, by being so closely integrated into SWOG, allows us to learn from the studies, learn from our patients who have so generously provided their willingness to participate on studies and undergoing biopsies to get these models. And now we can use this to help generate the next generation of studies. So I want to acknowledge certainly many members of the lab who are doing this work, a lot of great collaborators and mentors, including Lee Ellis, who has really, I think, helped push and inspire a lot of the work in colorectal cancer through SWOG. Certainly SWOG itself and the Hope Foundation certainly for the ability to have the resources to enable taking our clinical trials to the next level so that we can accelerate the pace of development. So thank you very much.
Thank you. Now,